G'day, welcome to Tech Math Channel. I'm Josh. In this video, we're going to be having a look at the index laws. So first off, what are indices? Now indices, these are powers that can be used to represent repeated multiplication of the same factor. Sounds like a bit of a mouthful. I'll give you an example. Say for instance, we had something like this. Say we had 2 times 2 times 2 times 2. This would be equal to, in index form, 2 to the power of 3. We're just literally saying we're multiplying 2 by itself 3 times. Or say for example, we had something like this. 5 times x times x times x times x. We could write this in index form as 5 multiplied by x 4 times. 5 times x to the 4. So that's what an index is. But what are the index laws? Now the index laws are rules or shortcuts that we can use when adding, subtracting, multiplying or dividing two or more indices together. So, for example, and this is a great segue to get into index law 1, we're going to have a look at if we wanted to multiply two indices together. So say we wanted to multiply the following. We had x to the power of 3 and we wanted to multiply this by x to the power of 2. What would this be equal to? Now using the index laws, we can work this out really simply, but I'm going to show you how to work this out the long way first. As you can see here, x to the power of 3. This is equal to x multiplied by x multiplied by x. And to this, we're multiplying x to the power of 2, which is x multiplied by x. And then we are multiplying these two together, like we said. Now you can see quite simply that this is x to the power of 1, 2, 3, 4, 5. This is x to the power of 5. So how do we solve this using a shortcut? Well, you might notice, all we need to really do with this is we keep that same base there. We have the common base of x, and that's our answer there. And then we have the two powers here. We have 3 and 2. We literally add these together. So 3 plus 2 is equal to 5. So that gives us the first index law, which is this one right here. So the first index law says you can have a base of, say, a here, and we raise that to the power of m, and we are multiplying this by a to the power of n. This is equal to the same base of a, and then we get the power of m and we add that to the power of n. So that's the first index law here. We keep that same base and we add these two guys together. So what about another example here? I'll make this one a little bit harder. So say we had this example here. We have 3a to the power of 2 multiplied by b, and this is being multiplied by 4ab to the power of 3. And we'll see what this equals. Now, once again, we could use this index law pretty simply to work this out. We could go through and do this, but being a pain in the bum, I'm going to write this all out here. So we'd have 3 multiplied by a multiplied by a multiplied by b, and this is all being multiplied by 4 multiplied by a multiplied by b multiplied by b multiplied by b, and we're going to see what that equals. Now, as you're going to see here, the first thing we have to deal with are these coefficients here, where we have a 3 and a 4. Now we're multiplying, so we multiply these first. So the first thing you're going to do is you multiply these coefficients here to get 12. 3 times 4 is equal to 12. The next thing, let's have a look at some common bases. So if we first off have a look at a, we have 1, 2, 3 of those. So that's going to be a to the power of 3. As you can see, we're just adding those two bases together. 2 plus 1 is equal to 3. And finally what we have is we have the b's here. We have 1, 2, 3, 4 of those. So that's going to be b to the power of 4. As you can see, we have b to the power of 1 plus b to the power of 3, and that gives us b to the power of 4. So for our answer, we have 12, a to the power of 3, b to the power of 4. And you can probably see there how much easier it would be to use that index law rather than going through this process every time. So what about we get on to the second index law, which is very similar to the first index law, dividing indices. So an example of this would be, say we had m to the power of 5, and into that we divide m to the power of 3. Now you might be brave enough straight away to try and work out what this index law is, but I'm going to do that going through the working out and showing you how we work out this index law. So what's this equal to? So we could rewrite this out where we have m to the power of 5, which is m multiplied by m 5 times. So m, and all of this would be divided by m to the power of 3. So m multiplied by itself 3 times. So there you go, m to the power of 5 divided by m to the power of 3. Now we can go through and cancel these out. So we have an m here, and that cancels out this m here. This m cancels out this m cancels out this m, and it leaves us with our answer here, which is equal to m to the power of 2. So from this we can see the second index law if we are dividing indices. All we really do is we keep that same base there, so m is that same base, and we just subtract one power from the other. In this case, 5 minus 3 is equal to 2. So the way we'd write this out is as follows. Law 2 would be a to the m, and if you divide this by a to the n, this is equal to a to the m over a to the n, which is equal to a to the m minus n. So what about we have a look at another one of these? We have 8x squared y 5, and we are going to be dividing into that 4x y to the 3. Now I think you probably go through and just use this index law to solve this. Now first off, watch out for that coefficient to start off with. So we have this coefficient here, which is 8 and 4. And what we do is we just use this operation here. So 8 divided by 4, well, that gives us 2. The next thing we do is we're going to look at the x's here. So we have x squared and x, and we are dividing. So what we do is we subtract here. So we still have the x, and we have 2 minus that 1 up there. 2 minus 1 is equal to 1. So we don't bother draw that in. And then finally what we have is we have the y's here. We have y to the 5 divided by y to the 3. So we have that y there, and we have 5 minus 3, which is equal to 2. And that's our answer there, 2xy squared. Pretty cool, right? So what about you go a bit funky on this, and now we'll combine this up before we get to index law 3. So let's do this one here. We have 2a to the power of 3 multiplied by b, and this is being multiplied by 8a squared with b to the 3. All of this is going to go over the top of 4a to the 4 with b to the 2. Cool. So let's go through and solve this using index law 1 and index law 2. Remember, if we are multiplying, we're going to add the powers together, and if we're dividing, we're going to subtract. So the first thing we're going to start with is the coefficients here. So we have 2 multiplied by 8 divided by 4. So we can do that in one hit. 2 multiplied by 8 is 16, divided by 4 is equal to 4. All right. Next, what we have is we have the a's here. We have a to the power of 3 multiplied by a to the power of 2 divided by a to the power of 4. So we're going to keep that same base. We have the a, we have 3 plus 2. 3 plus 2 is 5, minus 4 is equal to 1. We don't bother write the 1 there, so that's all pretty good. And then finally what we have is we have these b's here. We have a b, we have b to the power of 3 that we're multiplying by, and then we divide that by b to the power of 2. So we keep that same base. We have the b, so we have 1. Remember, this is a 1 here, so 1 plus 3 is equal to 4, minus 2 is equal to 2. So there's our example when we combine index law 1 and index law 2. 4ab squared. Happy days. So let's have a look at index law number 3. But before we do that, I just want to take this as an opportunity to talk about just a little rule when it comes to indices, which is the 0 power. I think this always makes sense to talk about when you are looking at index law 2. Because the 0 power is this one here. Say you have something like a to the power of 0, this is equal to 1. Anything to the power of 0 is equal to 1. And I'm going to show you why this is using index law number 2. So say we had something like this. Say we had a to the power of 5, and this is divided by a to the power of 5. Now, what's that going to be? As you can see, we could use index law 2 here and go through and say, okay, well, what we were doing is we would subtract these. We'd get a, and then we would go 5, take away 5. This is literally equal to a to the power of 0. This is equal to 1. And why is this? Because you have a whole bunch of numbers here divided by the same bunch of numbers there. You have something divided by itself here, it's equal to 1, right? That's why the 0 power, a to the 0, equals 1. I'll give you another example. Say we had something like 2 to the power of 3, which we know 2 to the power of 3, 2 times 2 times 2 is equal to 8. And we divide that by 2 to the power of 3. And we'll see what that equals there. So 2 to the power of 3, as we know, is equal to 8, and 2 to the power of 3 is equal to 8. Using the index law, what we'd go through and we'd say, okay, 2 to the power of 3 and 2 to the power of 3. We're dividing there, we'd get these two powers here and we'd subtract. We'd go 3 minus 3. We would end up with 2 to the 0. And seeing what that equals, well, 8 divided by 8 is equal to 1. 2 to the power of 0 is equal to 1. In fact, any number to the power of 0 is equal to 1. And that is the zero power law that we have with index laws. So let's have a look at law 3. So index law 3, we're going to look at powers of indices. An example of this, say we had something like this here. Say we had x to the power of 3, and that whole thing there was being squared. What would that be equal to? Now we could go through and expand that out, where we'd say that this is equal to x to the power of 3 multiplied by x to the power of 3. All right, pretty easy. We use index law number 1 now to solve this. This would be equal to 3 plus 3 is equal to 6x to the power of 6. What's gone on with our powers here? As you can see, we have 3 and 2, and we have 6 over here. What we do, we multiply these two powers here. So this gives us index law 3. Law 3 says that if we have a to the m, and this whole lot is being raised to the power of n, this is equal to a with m times n. All right, so let's have a look at another example. Say we had 7x to the 3, and we get all that, and we square it. Nice and easy. Let's solve it using the third index law here. So the first thing I'm going to have to deal with is this coefficient here. So we have 7 squared. 7 squared, well, 7 sevens are 49. Now what we have is we have the x here. We have x to the power of 3, and that's being squared. So we have x, and what we do is we multiply these two here as law number 3 says. So 3 times 2 is equal to 6. We have our answer, 49x to the power of 6. So let's have a look at another example using some of the past index laws also. We have b squared. All of that is being raised to the 5, and that is being divided by b to the 4. Now you might see that we're going to be using index law 2 and index law 3 to solve this. So let's go and do this. Now I'm going to do this in 2 parts. You might be able to do it in 1, but I'm going to try and show you what's going on. So first off, I'm going to keep this as a number over. So what we have is we have b squared being raised to the power of 5 here. So what's happening here is we end up with b, and we multiply these two numbers here. This is b to the power of 10, and this goes over b to the power of 4. So what's this all equal to? Well, this equals b to the 10 divided by b to the 4. As you probably remember, we subtract. So we're going to end up with b, 10 minus 4 is equal to 6. That's our answer, b to the power of 6. Pretty simple, right? All right, let's move on to index law 4. So index law 4 is used when we're multiplying 2 or more numbers and we're raising all those to a certain power. We sort of did one of those a little bit earlier, so you can probably see where this is going to head. So an example for this is this one here. We have 5b, 2 numbers that are multiplying by themselves, and they're all being raised to the power of 3. Now, I'm going to show you the expanded version of how to do this and then the index law. Now, first off, what you're going to notice, 5b here, this here is equal to 5 multiplied by b. And then we're doing that 3 times. This is equal to 5 times b multiplied by 5 times b multiplied by 5 times b. This is equal to, well, first off, we have the coefficient here. You can see that's 5 multiplied by 5 multiplied by 5. This is 5 to the power of 3. And then here we have b multiplied by b multiplied by b. This is b to the power of 3. Now we could go through and solve this even further now. We could go, what's 5 cubed? 5 cubed is 5 times 5 times 5. That's 125 b to the 3. But this part here shows us index law 4, which is this one here. If we were to have this bit here, a multiplied by b to the power of m, this is equal to, well, no surprise here, we have a to the m multiplied by b to the m. So what we had in our example was 5b to the power of 3, and we ended up with 5 to the 3 and b to the 3. So we just raised each individual component to that power there. Pretty simple. So what about we go through a couple more examples on this one. We have negative 2x cubed multiplied by y, and all of that is going to be raised to the power of 3. We'll see what that is equal to using this index law right here. So we're going to go through each component here and raise it to the power of 3. So first off, we have the coefficient here, negative 2. So we'll have negative 2, and that's being raised to the power of 3. Next we have x, that's being raised to the power of 3. So this is going to be x cubed, and that is all being raised to the power of 3. And then finally we have y to the power of 3. So y to the power of 3. Now let's go through and finish this off. So negative 2 to the power of 3. That's negative 2 multiplied by negative 2 multiplied by negative 2. That's going to give us negative 8. Now what we have is x cubed, and that's all being raised to the power of 3. Now if you remember that other index law we used before, that was index law 3. We are going to multiply these. So that's going to give us x to the power of 9. 3 times 3 is 9. And finally we have y to the power of 3. Pretty simple, right? A nice easy index law. None of these are that hard. They kind of make a lot of sense when you look at them. What about one more example? I'll make it a little bit harder. So what about we have 3, we have c to the power of 2, and we have d to the power of 4, and that's all being raised to the power of 3. I seem to really like raising the power of 3, don't I? I don't know why that is. So what about we go through and solve that using this index law here? So as you can see, we've got some different parts here. Now, it's only this part in the brackets which is being raised to the power of 3. So that's the only part that index law 4 will apply to. So let's just first off write this coefficient down. That's going to stay the same. That's just going to stay as a 3. Next, what we have is c to the 2. I'm going to put that in brackets. And that's being raised to the power of 3. Then we have d to the 4. And that's being raised to the power of 3. Go through and solve this now. Simple. We have 3. For c here, we have c. And using that index law 3, we are going to multiply these guys here. So 3 times 2 is equal to 6. And then we have d. And once again, using index law 3, we multiply these guys here. So we have 4 times 3 is equal to 12. There you go, happy days, nice and easy, index law 4, bang that one out. Now, index law 5, and we're almost there. We've almost finished all these index laws. Pretty simple, right? Let's have a look at index law 5, the final of the index laws we'll be looking at. So index law 5. As you can see, what we're doing is we are dividing two numbers and then raising them to the power of m. Now, knowing index law 4, you can probably easily think of what this is going to be, but you know, I'm going to actually work through this with you using an example. So the example we're going to use is this one here. Say we had 3, and that was placed over the top of x. And then we get all of that, and we are going to raise it, not to the power of 3, let's put it to the power of 4. Okay, so what are we going to do this? Now, if I was to draw this out, we could see that this would be equal to, well, this is basically 3 over x multiplied by itself 4 times. So this would be equal to 3 over x multiplied by 3 over x multiplied by 3 over x multiplied by 3 over x. Cool. Now, can you work this out? Well, multiplying fractions here is nice and simple. We just go through and multiply the top, and then we multiply the bottom here. And we could solve it like this, but I just want to draw your attention first off to something here, which is this. This here is equal to 3 to the power of 1, 2, 3, 4, 3 to the power of 4, and the bottom part is equal to x to the power of 4. And that's going to give us index law 4 here, which is this one here. Say we have a over b, and we raise that to a power of m. This is equal to a to the power of m over b to the power of m, which is like what we have here, okay, where this has become 3 to the power of 4 and x to the power of 4. Simple. But like I said, we could expand this just a little bit more. So let's go through and do this. This is equal to 3 to the power of 4. That's 3 times 3 times 3 times 3. That's going to be 81 over x to the power of 4. Cool. That's index law 4. Nice and simple. What about a couple more examples? So what about we try negative 2a, and that's going to be the power of 3, and that can go over the top of 3bc to the power of 2. That whole lot there can be raised to the power of 4. So we're going to start solving this using index law 5, and then we're going to use some other index laws to finish it off. So first off, we have negative 2a, and that's to the power of 3, and that is being raised to the power of 4. And this is all going to go over the top of, now this part here is also going to get raised to the power of 4. So we have 3bc squared, that's then going to be raised to the power of 4 also. So we can take this a little bit further now, where we go through using other index laws to solve this. Using that third index law, we can expand this bracket out now, where this is going to give us negative 2 to the power of 4, negative 2 to the power of 4. This is negative 2 times negative 2 times negative 2 times negative 2. That's going to give us the answer of 16. We have a to the 3 raised to the power of 4. Now remember, with our index law 4, we multiply these. So this is going to give us a to the power of 12. This is all going to go over the top of, well, we have 3, the coefficient here, raised to the power of 4. That's 3 times 3 times 3 times 3, which is 81. And that's going to be now b to the power of 4, b to the power of 4. And we have c, and we multiply these guys here. 2 times 4, c to the power of 8. So this can't be simplified any further. We have our answer. I'm not going to go through and read all that. You can read that if you wish. But that's how we go through and use index law 5. So that is the 5 index laws. In another video, we will be looking at negative indices. But right now, I'm going to actually give you a couple of these that are a fair bit harder than the ones we've already looked at. So let's have a quick look at this one here. A to the power of 3 multiplied by b. All of that can go over the top of c. This all will be raised to the power of 3. And we're going to multiply that by ac to the 4. We'll put that over b, and all of that can be squared. All right, see how good you are? Go through and try to solve this. All right, so the way that I'd attack this particular one. So first off, we're going to go through and we are going to expand these brackets out a little bit. So we had a to the power of 3, and that's going to be multiplied by a to the power of 3 there. So a to the power of 3, if we look at the a's here, we have a to the 3 multiplied by a to the 3, that's going to give us a to the 9. We then have b to the power of 3, so b to the power of 3. This is all going to go over the top of c to the power of 3. All right, this is being multiplied by a squared. We have c to the 4 being squared, so this is going to be c to the 8. And this is going to go over the top of b squared. Cool. So now let's go through and solve this. We're going to have an answer with the divide still in it. Well, maybe we won't, but we'll see. But let's put that there just to help us out. So first off, we're going to deal with the a's here. So we have a to the 9 multiplied by a to the 2. Easy. That is a to the 11. Next, we have the b's. We have b to the power of 3. Over here, that's being divided by b to the power of 2. b to the 3 divided by b to the 2 is equal to b to the 1. So we don't bother put that one there, we just leave that as b. Now let's deal with a c here. We have c to the 8 divided by c to the 3. So c to the 8 divided by c to the 3 is equal to c to the 5. So there you go, that's been solved. That's all pretty good. Nice and simple. We don't even need that bottom part there. There is our answer. A to the 11 multiplied by b multiplied by c to the 5. What about one more hard one here? So for our final index law question, let's go 4m squared n, and that's going to be multiplied by 3. We'll open brackets, call that m squared with an n there, and we'll raise that, close brackets, to the power of 3. And that will all go over the top of 6m squared. And what about an n there as well, just to round that off. Now go through and try to solve this using all those different index laws. Yeah, you done that? Cool. Let's go through and solve this now. So what is this equal to? This is equal to the following. Okay, so let's start out with our 4m squared n. I'm not going to do anything with that for the minute. I'm going to leave that just how it is. So m squared to the power of n, because really at the moment, what I want to do is open up these brackets here. So that's going to be 3 multiplied by m squared to the power of 3. Remember that index law? We multiply these guys. So this is going to be m to the power of 6, and we have n to the power of 3. Let's put that all over the top of 6m squared multiplied by n. So let's go and finish this off now. So what does this equal? First off, we're going to start with the coefficients here. The coefficients, we have 4 multiplied by 3 divided by 6. 4 times 3 is 12, divided by 6 is equal to 2. Now let's have a look at m. So we have m squared multiplied by m to the power of 6 divided by m to the power of 2. So 2 plus 6 is equal to 8, minus 2 is equal to 6. Cool. Finally, we have the n's. We have n to the 3, and n there. So n multiplied by n to the 3 divided by n here. So you probably remember these are both to the power of 1 here. So 1 plus 3 is equal to 4, minus 1 is equal to 3. And there you have it. We have our answer, 2m to the power of 6, n to the power of 3. And that is the index laws. Hopefully you like this video. It's pretty marathon today. As I said, coming up there will be the negative indices video. Now, if you like this video, please remember, hit the like button and subscribe. A big shout out to my patrons and subscribers. And you'll also notice that I have now got a join button. If you wish to join the TechMath channel, you can also do so on YouTube. You can do so on Patreon. I know this is a shameless grab for cash on my part, but you know, we do put videos out there, so it is always appreciated. But you can join the TechMath channel and support free maths by paying for it. You know, and if you do that, you'll get very little off me, I will say that, but you know, you'll get a warm and fuzzy feeling going your way. Anyway, thank you for watching, and I will see you next time.